Can everybody hear me? Yeah, I see. Yes, it's a bit strange. I'm basically talking to myself. But yeah, it is what it is. Okay, thanks for being here. It's around 2 o'clock, so let's kick this off. My name is Koen van der Poorten, solution engineer at F5, and I will be entertaining you about a recent solution of ours, which is basically our SaaS solution. Now, of course, every solution needs a problem, or it would not make sense. So I decided to make this story around Killnet, which you may or may not know, but in any case, which you should know about, because it really shows the value of what we can bring. So here's the short agenda, but I will first obviously introduce the problem and then go over the ways how we can basically fix the problem. So Killnet, maybe you know it, maybe you don't know it. This is the definition I found on the internet. So it's a pro-Russia hacker group, which is known for DDoS attacks. They basically started out as a DDoS for hire group, pretty amateuristic back in the days. But in the beginning of the war in Ukraine, they went full political, let's say it like that, and they've been harassing companies or institutions which help Ukraine in the war with DDoS attacks. So in the beginning it was pretty much, I would say, amateuristic, but of course they have been maturing over this last year. And what is particularly, let's say, worrying is that they are starting to partner with other hacker groups. Like, for example, there is another Russian group called Passion, which does focus on botnets. And of course, a mixture of attacks, as we will see, can be pretty tricky to stop and can do serious damage. Here's a couple of screenshots of articles I found on the web, just to show you what these guys do. It's mainly about DDoS, obviously. And if the country, in Holland, Germany, Belgium, if the country helps Ukraine out in the war, these guys will see you as a potential target, or will see your company as a potential target. First of all, let's define what is a DDoS attack, because there's a bit of misconception around it, and I want to make that clear before we go into the details on how to fix it. So, DDoS, what is it? Commonly, what people see as DDoS is often volumetric DDoS, and that is the practice of sending a lot of traffic, very large sometimes, but a lot of packets to a certain resource. Could be a server, could be a router, could be some gateway, in order to overwhelm it. Okay. Typically, what do customers or what do institutions or enterprises do to protect themselves against that? They engage, well, the ISP, for example. But what if you have multiple ISPs, and then you need to ask multiple ISPs for protection, and it's not, you don't have a very good overview of what is happening. And what these ISPs often focus on are these volumetric DDoS attacks. But there is more than that, and that's the problem with this. As another family of attacks is application layer DDoS, so it doesn't play on the networking level, but rather on where your application lives, on layer 7 as we know it. So what happens there is they will try to abuse, for example, the HTTP or HTTPS protocol by opening connections to the server and keeping these open for a very long time in order to saturate the session table. That's one flavor. But it could also be an abuse of the logic of the website. Say, for example, that I have a web shop, you want to attack me, then you would log on to my web shop just like a regular user, and then you take an item, you put it in a shopping basket. but you do not do that just once. You do it, you launch a script, for example, that does it 1 million times per second or 1,000 times per second, and you let it run. So what happens is, this is not going to generate a lot of traffic, obviously, a few hundreds of kilobits per second. It's not going to trigger this volumetric DDoS protection because there's not much to see over the wire. But for your application itself, for the backend, for the database, etc., it's a disaster because they have to perform all these queries, and regular users on your web shop will not be able to do anything useful because, yeah, it's all going very slow. And in the end, what happens? Well, they will go elsewhere. So that's application layer DDoS, very important, and it takes a different type of protection. That is important to keep in mind. Now, another thing is that DDoS is often used as, let's say, a smokescreen for other attacks. So while there is somebody is banging on your front door, making a lot of noise, so you have your monitoring applications triggering and red lights everywhere. Everybody is focusing on the DDoS attack. Maybe via some backdoor or via another channel, they are sneaking in other communications like SQL injections or really application attacks. Okay, so most of the time it's not just one of these types. It's volumetric DDoS attack combined with other stuff. Okay, very important. Now, what is a consequence of these attacks, or what are these hackers looking for? Well, they look for data exfiltration, which they could do, for example, through the application attacks, or maybe your database crashes, you lose a lot of your data, also possible. But obviously, what is visible to the outside is the reputational damage. For example, Amazon or Bol.com, for example, has had downtime, and you will be reading that in the newspaper the day after. Also, for a web shop, for example, it's critical to have a good application. It is Bol.com, it is an application. It's no, there is a lot behind it, but to the outside world, it is an application. So if these customers see that it's not going very fast, they will maybe go to Amazon, for example, or to the Amazon store or other stores. Financial loss and downtime, stores. Remediation costs, do not underestimate that. You will need a lot of cleaning up, especially when it is combined with application level attacks. When the attacker managed to plant, I don't know, a Trojan or some malware in your network, it's going to take you time and money to clean it up. And then in the end, ransom attacks. More and more DDoS is being used for extortion as well. So what happens is, the Killnet, for example, they will do a DDoS attack to the network, to the outside network of a customer or maybe a hospital, which takes some time to clean up, but which is not that bad in the end. But following to that, they will send a message to the institution saying, yeah, this was just a starter, a quick starter. And if you are not paying us, or if you are not doing this or this or this, we are really going to wreak some havoc on your network, okay? So it's really ransom, not especially for, could be financial, but also for other means of pressure, maybe political, for example. So, how do you protect yourself against that? We've seen that there's multiple types of attacks going on at the same time. So what you need to do is you need to have multiple types of defense against that. One single technology will never be able to protect you against that. That's a given. So you will need different layers, and I like it to call it a digital shield, which you put in front of your applications, which is going to filter out the attacks. And it goes from maybe the first layer could be volumetric DDoS protection. After that, you may have, let's say, the application DDoS filtering. It's a different technology. For application DDoS, for example, in order to stop that, you need a layer 7 proxy, which is a whole different beast than what you would use for volumetric DDoS, okay? And then you have other stuff like bot detection, signatures are also useful, but just keep in mind, it's always layered. So in the end, what do you need in order to protect yourself from that? Well, before I get into that, another thing, it's never as simple as this, okay? Before 2010, we had our applications in the data center, the monolithic applications, one single space to protect. Then people thought, okay, we're going to shift everything to the cloud, one single cloud, the applications are there. But the reality is very much different, okay? So what we see now is this. Applications are hybrid. You may have the front end of your application in Azure for performance reasons, but maybe the back end, the database, for example, you might run it on site for privacy reasons, or maybe for cost reasons, or maybe it just doesn't, it's an old database that would just not run in the cloud anymore. Okay, so it's a mix of environments. And another thing is, in 2010, applications were by default, let's say, monolithic. That means that all the functionality is in one big block of code. That's not the case anymore either. We've seen the rise of containers, Kubernetes. So that means that that big application, we've been pulling it apart into different parts. A container that runs the front end, for example, another container that runs a shopping cart, for example, and they may run in different places. You may have that front end running in Azure. Your shopping cart may be, for whatever reason, maybe because it's serverless, maybe running in AWS, etc., etc. And so it's become a lot more complex, the environment, the application, and also the attacks have become a lot more sophisticated. Hackers are intelligent guys, so it's like an arms race that we need to defend against. So what would you need to defend yourself in this case? Well, you would need this. You would have to put in place all these different solutions, maybe from different vendors, WAAP, authentication, anti-bot protection. You would need to make sure that everything goes smooth. So you need that the load balancer, etc. So there's a whole lot of technologies that you need to chain together to put in a conga line, as we call it. And you need to do that for your different environments. So on-premise, you will probably have different solutions than in a public cloud or on the edge. And even worse, you need to address different teams. So you will have the security guys doing their thing, you will have the networking guys doing their thing, but also the application guys, the API developers, for example, or the application owners. And obviously, that's complicated, as you have seen. Fortunately, we have a nice solution for that, which we will use to streamline this whole process. And it's called Distributed Cloud. It is our SaaS solution that we released, let's say, last year. And so instead of having different environments with different GUIs, different solutions, what we can offer you is one single solution. It's a SaaS solution, so it's a dashboard that is running or accessible in the cloud. And we don't care where your application lives in this case. Could be on site, could be in a public cloud, could be in an edge location. We offer you all these different point solutions from one vendor in one single interface. It's a multi-tenant space, so whether you are a security guy or a networking guy or an applications guy, you will find the tools that you need. It's totally, you can drive it through an API as well, so you can automate this with your existing tools as well. And this this offers you collaboration, the ways or the means to automate. There's very advanced security in here. With F5, either we develop something ourselves, like our WAAP. It's a state-of-the-art web application firewall. But for example, for bot detection, we have purchased or acquired a company called Shape Security. And these guys are very strong when it comes to bot detection and fraud detection and mitigation. And so we have integrated all this technology into this SaaS solution. Advantage of a SaaS solution, obviously, it can be zero footprint. You don't need to install anything. You don't need to manage the life cycle of this solution. You don't have to start it up or upgrade it. We do that for you. You just configure it and manage it day to day. What does it look like very quickly? So it's a global network. It's we have a backbone spanning across the world, 25 POPs or something like that, which you can use to access the SaaS network. Now, what is very particular here is that you can extend this network on the internet or your local network by deploying what you could call a local POP. Okay, so you start up a virtual appliance in your data center, for example. It will reach out and connect back to our network, and then your network has become part of our network, and you can start configuring and deploying your local services, and also expose them to the outside network. Again, always with one single interface to manage. Here's a view of the world with all our POPs, and you see that in particular Europe is well served. So each customer, let's say that I'm that web shop, I'm leveraging this network. So what happens is that customers who want to access my shop will first access one of those POPs, where we will do all the filtering, etc., and then they will be able to access the shop that may run in your own network, in Azure, maybe even in our network. We support that as well. It's a highly resilient network. We are in the top 10 for connectivity, global peering, as you can see here. We also have high-speed links to public clouds. So accessing our network and then going to Azure is quicker than going to Azure directly. So here's the platform, and so you can use it to link your different networks together. Out of the box, you will also have ADC services or application delivery services, load balancing, reverse proxy, IP optimization, etc. DNS, there's also a caching network in there, CDN, if you want to use that. We can link to your private network via private lines if you want to. And then on top of that cake, we have a couple of cherries here. We can protect your applications, we can connect your applications, and we can deploy your applications. You can even use it to deploy applications on. Today we will be focusing on this. Okay, I'm not going to talk about connect and deploy. It would bring us too far, but let's have a closer look at these guys. So, I'm going to introduce a nice acronym, WAAP, which is Web Application and API Protection as a Service. Okay, it's a mouthful, it's horrible, but this is what it is. We give you different types of security. Think back to that onion, the different layers of the onion. This is basically what you get. So the whole WAAP story, and I will go into more detail on that one. We can also secure the underlying infrastructure, and then I will not talk about these today, but you have some nice additional ways to protect your applications, for example, against stolen credentials. If somebody tries to access your your portal with a pair of credentials that was stolen in a previous hack, we will notice it, we can alert you to that, okay? Client-side defense is more towards what we call supply chain attacks. But I'm not going to go into detail there, but again, one single interface, multiple networks, your applications can run anywhere. So let's talk about the first part of WAAP. So that is the Web Application Firewall. The Web Application Firewall, you probably know the technology. It's basically a reverse proxy that you use to filter out unwanted traffic. So obviously we use signatures for that, like everybody, that's a given. But signatures are not enough, because they will only do so much to protect you. You need something else on top of that. Now, the thing is, this is a SaaS solution, and since SaaS is so scalable and has so much resources, you can start to leverage artificial intelligence and machine learning. You probably saw that coming. We use it as well. I'll talk about that. First, a quick screenshot of the GUI. We provide you with the visibility, with the dashboards in order to drill down in what is going on your network, which alarms are triggers, which attacks are stopped. So we try to, at the same time, we try to make it very, very strong out of the box, okay? The default configuration is already very good. We use machine learning, etc., to minimize false positives. So you can be sure that by just using a default configuration, in this case, you already have closed a lot of holes or possible holes in your security. And on top of that, we have what we call user behavioral analysis. So this is where the AI and the ML comes in. We track users across on their journey across your application. They click here, they enter a username and a password, then they are moving the mouse, etc. They do all kinds of stuff. And we use the machine learning in order to score that customer or that client. Okay, when we see something suspicious, the score will rise. When he does the usual stuff, the score will go down. But this way, you can start to block users when the score is above a certain threshold. We've already discussed DDoS, so I've been talking about volumetric or network DDoS, and then the application layer DDoS. So no need to go into detail here. Just know that we give you the visibility, the worldwide visibility, in order to see when these attacks are taking place, where they are taking place, and from when you are being targeted, because that might be interesting or useful information. You can also create your own rules. For example, you could choose to block source IP addresses from a certain network or ASN or country if you want to. But this will help you visualize it and take action. APIs. We all know that APIs are becoming very important recently. They are being used, for example, for a mobile app. If I have an app on my phone, the way it communicates to the backend is through an API calls most of the time. Or it could be a subcontractor of yours that want to consult a database in your network. And usually the way to expose those types of applications on your network is through APIs. So an API is like some kind of a web server, but not really, okay? Instead of exchanging HTML pages and pictures, you're going to exchange JSON files when you're using a REST API. So you need a WAF, but not just any WAF. You need a WAF that has this knowledge of this API traffic, okay? And that's where this solution comes in. We will be able to look inside those JSON packets. You will be able to upload API schemas or Swagger files so that we immediately know what your API looks like and start to defend it out of the box. So most of you will probably know OWASP Top 10. Yeah? It's the, let's say, a top 10 of the most critical problems that your application or your web application has, or the errors that your developers make. Authentication, for example, or broken authentication. Now, since a couple of years, OWASP has also started releasing this for APIs, which just shows that it's an important problem. So, wherever you've seen the green ball, that means that we can help you protect that, okay? So, with a lot of these 7 or so, we can, right out of the box, help you. And a couple of those were still either in the works of doing this, of putting this technology in place, or it's just beyond our scope. That's also possible. But to be, let's say, in a nutshell, it's a very good solution for protecting, exposing and protecting your APIs. And then finally, bots. Well, what is bot traffic? Well, bot traffic is automated traffic. Now, you may know that more than half of the traffic on the internet is automated in some way. And of that portion, all that automated traffic, one part is good automated traffic, the other part, the biggest part, is bad traffic or useless traffic. What are botnets, or what is automation used for? Well, specifically the malicious one. Well, for DDoS attacks, for example, for executing the WAAP attacks, active attacks like SQL injection or cross-site scripting, for reconnaissance, or just for sending rubbish in order to confuse or obfuscate other stuff. So if you can right out of the box already drop most of that malicious traffic, automated traffic, then you're already halfway there, because the DDoS attack or the automated attack will not even reach the web application firewall, let alone your application. So this is a very important point. How do we protect you? Well, we have signature-based bot detection. I already spoke about our signatures. The user behavioral analysis, which I already mentioned, the AI/machine learning mechanism. And on top of that, I spoke a couple of slides ago about shape security. These guys, they have a worldwide network. They have very intelligent technology that can help you against bot attacks or fraud attacks. And they continuously relearn and update their software. And if you want to, you can also, by a license upgrade, start leveraging that one. Finally, I've been talking about the application, but obviously there's more than the application. Your application needs to run somewhere. On VMware, on a virtual machine, in a cloud, in a container, on Kubernetes, for example. And so it's also important to secure the underlying environment. You can use networking security, obviously, like firewalls, etc. But you need something, for example, to protect the Azure portal, or in any case, alert you when there's stuff going on there that shouldn't be happening. Vulnerability assessment. You may want to make sure that there are no CVEs in the software that you're running. File integrity monitoring, intrusion detection, container security. If you run Kubernetes, for example, is it well configured or not? And threat intelligence. We do that by leveraging rules that you can create yourself, or machine learning, again, obviously. Now, just to finish this off, let's have a look at problems that may arise for this underlying architecture. Well, for your cloud interface, for example, your Azure portal, for example, credentials may be stolen, or stolen credentials may be replayed in order to access it. Suspicious logins, a firewall may be deactivated for some reason in Azure or in AWS. You want to know about that, obviously. Virtual machines may have their kernels modified by malware. There may be lateral movement, an attacker jumping from one VM to another, for example, may be suspicious. On the orchestration level, when we're talking Kubernetes, for example, it's very easy to download a container from Docker Hub and spin it up without even controlling what it's doing. So you need to be able to scan these containers and make sure that they only do what you approve. RBAC needs to be put in place, etc. And then finally, the containers themselves. You may have, again, that lateral movement between containers. You may have container that is doing crypto mining without you knowing it, etc., etc. So there's a whole host of problems here that we address with what we call AIP, which is application infrastructure protection. Okay, another layer in the onion, so to speak. And that's basically what I wanted to talk about. So I used, let's say, Killnet as a coat hanger for this, for telling this little story, but it's a very important topic. If you expose applications to the internet, make sure to secure them in different ways. Don't just put a firewall in front of them, that's not going to help you. You need something that is intelligent enough and is multi-purpose enough to protect you. So efficacy and agility, this solution is able, you can configure it through an API, so you can integrate it in a CI/CD pipeline if you want to, or rather your developers can do that. You can deploy it anywhere in our cloud or on site. It will protect you anywhere, whether your application is on site or in the cloud. And then common platform, you have these multiple types of protection for that work hand in hand, chained like a conga line. Okay, thank you. If you have any questions, please stick around and ask me. But in any case, thank you for your time and have a nice afternoon. Thank you.